Hello and welcome to video number 6,328 of my 28,932 part series. This video will be on writing equations in slope-intercept form. Now we've already done this a little bit. We know that m's the slope and b is the y-intercept. The problems we're going to be dealing with today are a little different. Excuse me. Let's take a look-see, shall we? All right. So let's think about what's the bare minimum. What is the bare minimum you need to be able to graph a line? The bare minimum amount of information required to graph a line. You can graph it if you have 2 points that you know are on the line. You can also graph that line if you have 1 point on the line. And so a point and the slope. Okay. That's 2 possible ways to graph a line. Now it turns out that you need exactly the same amount of information, or it's helpful to have the same amount of information when you are given information and you're asked to do the same process algebraically. So first let's take a look at these 2 examples. Okay, if I have a point here and a point here, it's not very clear what the line between those are, and I didn't do a great job there. It's okay, we could kind of drag it down center a little bit. It looks like it crosses at about 8.5, but it's not, it's hard to tell for sure. We don't really know exactly where the line crosses. So if you wanted to write this in slope-intercept form, well, you could find the slope, but the y-intercept is not very clear. So how would we do that? How would we find the y-intercept when we want an exact answer here? Maybe it's 8.5, maybe it's not, maybe it's 8 3/5. It's hard to tell. Okay, so but it is possible to graph a line with 2 points, and we know that there's only one line that can travel through those 2 points. Let's get another color. Actually, let's get the line tool. All right, what if I wanted a line that had a slope of 1/2, which this one does? Now, how many lines have a slope of 1/2? There are an infinite number of lines that could have a slope of 1/2. But how many lines have a slope of 1/2? Hope I didn't ruin it. That's pretty close. How many lines have a slope of 1/2 and travel through this point? Well, ladies and gentlemen, there's only one of those, and that is this line right here. This line has a slope of 1/2, and it travels through that point. Okay, so you can either have 2 points. This is probably bugging some people. I'll fix that. You can have 2 points to graph a line, or you could have a point and a slope, and that's enough information to graph one line. Turns out to be the same algebraically, and I'm going to show you how to do that without using graph. And you can basically always get a perfect and correct answer. So ladies and gentlemen, prepare to witness the power of algebra. All right, take a look at this example. It says, write the equation of the line that passes through 3, -3 and has the slope 3. Well, let's think about this for a sec. The equation is y equals mx plus b. You've given me the slope, so if I'm writing it in slope-intercept form, my equation is going to be y equals 3x plus b, but I still don't know what b is. So that means I don't have the equation of the line, and this isn't the y-intercept. If I gave you an equation like this, it said write the equation of a line with slope 4 that passes through 0, 6. Well, 0, 6, that's the point that is my y-intercept, so writing this in slope-intercept form is easy. We plug in 4, and we write -6. Game over, right? That's slope-intercept form. We're done. Here we don't have it. So you're probably thinking, well, I could just bust out a graph and we could figure that out. Yeah, you can. It's totally reasonable to do that if it crosses the y-axis on a nice, easy grid line where it's easy to see and it's easy to read and we can tell. And I think it will in this case, but let's take a look. So has the slope 3, passes through 3, -3. Let's take a look. 3, -3 is right here. It's got the slope of 3, so when I go down 3, I'm going to go back 1, down 3, back 1, down 3, back 1. So that'll be 2 past 10, which is 12. So it should be -12. Whoops. It should be -12 is our y-intercept. So select all this stuff. Perfect. Okay, so we know that we should get -12 as an answer. How do we do and see that algebraically? So what we're going to do, step 1 to doing this process, step 1 is to plug in the slope, which we've already done. Plug in the slope is step 1. Plug in 2, so basically plugging in the slope is basically what I did with the line, this line at the very beginning. I said, hey, here's a line with a slope of 1/2, right? And it could be anywhere. So how do we restrict it? We have to have the point and we have to plug that into our equation. So I'm going to plug in or substitute a point on the line. I know that the point 3, -3 is on my line, so I'm going to go ahead and plug that into my equation for x and y. So the x coordinate is going to go in the x position right here, and the y coordinate, -3, is going to go in the y position right here. And the rest of the math that we're going to do, I'll do in black. So I plugged in, whoops, goofed that up. Plugged in -3 in for the y slot because it's in the y slot of the point. So we end up with, God dang it, this color thing, black. Okay, we end up with -3 equals 3 times 3 plus b. And so now we can simplify this to solve for b. There's only one unknown in the equation, and that's b. So it's going to be -3 equals 3 times 3 is 9 plus b, which gives us a value of -9 from both sides. -12 equals b, so b is equal to -12. Great. So what is the equation? The instructions say write the equation of the line, and we're going to do that in slope-intercept form. We now know the slope is 3, and we know the y-intercept is -12. So we plug in y equals 3x minus 12. So what we've just done, the act of plugging that point in was the same as me dragging it down and forcing it to go through this point. Now technically that's a different line than this is, but it's the same basic idea. So let's recap the rest of the steps that Mr. Slagle did not write down. Plug in a point on the line. Step 3 is solve for b, our y-intercept. And then the last one is rewrite the equation. Great. And that's how you take a slope and a point and use algebra to discover the equation in slope-intercept form. So how about the point 1, 5, and the slope -1? You guys try this by yourselves, see if you can do it, and then I'm going to go through it here in just a sec. We'll do this one in green. Sounds like fun. Okay, I'm going to start. So pause the video if you want to try. Okay, y equals, I'm going to plug in the slope of -1, -1x plus b. Now I'm going to plug in my point. My point is 1, 5. So 5 goes in for the y, -1, 1 goes in for the x, plus b. Multiply those two, and you get 5 equals -1 times 1 is -1, plus b, add 1 to both sides. You end up with 6 equals b. Fantastic. So my equation is y equals -1x, or just -x, plus 6. It's kind of fun. Great. Here's another one. This one's a little different. It's okay. All right. Yeah. Yeah. So you guys can, I'll just do this one. I have extra examples in here. If you need to see another example, great, watch it. If not, you can move on to the next set of problems, but I'll just do it anyway. Okay, this is a slope of 0.3 repeating. If you want to write any number with a repeating pattern as a fraction, you just take basically the pattern that's repeating, which is just a 3, and put it over the number of digits, or put it over the number of 9. Put over it over a number of 9s equal to the number of digits that is repeating, which is just 1. So 1 9, which simplifies to 1/3, or you just recognize that decimal. Okay, so y equals 1/3 x plus b. All right, so now we got to plug in. That's -2 equals 1/3 times 3 plus b. 1/3 times 3. 1/3 times 3 over 1. Go over and do an aside if you need to. Well, those are just going to cancel. You'll end up with 3 over 3 or 1. So that -2 is equal to 1 plus b minus 1 minus 1. And you end up with b equals -3. So our equation here is y equals 1/3 x minus 3. Lots of fun. Hope I did that right. Super. Okay, let's go ahead and move on. So what we've just accomplished, running back, we have just accomplished solving with a point and a slope, finding the equation. Now we're going to tackle when you're given 2 points. So write an equation of the line through 3, 5 and 2, -2. Oh boy, let's do this. So I don't have a slope, so I can't start this process. I can't say y equals mx plus b and plug it in because I don't have the slope. So that is step 1. When you're given 2 points, first you got to find the slope. This is when you're given 2 points. Find the slope. So we do m equals, we're going to use that equation, y2 minus y1 over x2 minus x1. And then you are going to plug these values in. y2, we'll call this 0.2, this one 0.1. It's going to be -2 minus 5 over 2 minus 3. So -2 minus 5 is -7. 2 minus 3 is -1. Negative divided by negative is a positive. 7 divided by 1 is 7. Great. Now we have the slope, so we can continue. We can plug in to our equation. It's going to be y equals 7x plus b. Oh, but wait. We have 2 points now. Which one do I grab? Or does it matter? Well, why don't we do both and see if we get the same answer? Okay, so I'm going to use 0.1. What if we plug in 0.1? We plug in 0.1, we get -2 equals, sorry, that's 0.2. We get 5 equals 7 times 3 plus b. Multiplying those, that's 5 equals 21 plus b. Solving for b, we're going to subtract 21 from both sides, and you will get -16 equals b. So b equals -16, which means our equation in slope-intercept form is y equals 7x minus 16. Nice, clean, whole numbers. This will be fun. And then over here, 0.2. Okay, 0.2, we are going to plug in -2 for y is equal to 7 times 2 plus b. So -2 is equal to 14. 14 plus b, subtracting 14 from both sides, will give us our b equals -16. So look at that. We get the same answer. It does not matter. It does not matter which point we pick, because both of those points are on my line. They hold the identity of the line. Okay. Super. All right, let's go ahead and move forward. You guys can try this one. I'll work it out here in just a minute. You guys give it a shot. Yeah, pause the video. Okay, it's been long enough. Let's go. Find the slope. Step 1. y2 minus y1, x2 minus x1. Plugging in points, that's -2 minus -10. We've got the minus from the equation, but also the negative from the 10, and you have to include both. Then you have -3 minus 5. Let's go ahead and simplify the top. That's -2 minus -10 is +10, and on the bottom, -3 minus 5. Those are going to become more negative. All right, -2 plus 10 gives me a +8 divided by -8, which is going to simplify to -1. I found my slope. That's step 1. Step 2 is business as usual. Plug it in, and we're going to pick a point. It doesn't matter which one we pick. Y equals -1x plus b. Let's go ahead and plug in -2. Numbers are smaller. Works for me. -2 minus 1 times x is -3 plus b gives us -2 equals +3 plus b. Subtract 3 from each side, and b is equal to -5. So that's not our answer. Slagle. Our answer is the equation, which is y equals -1x or -x minus 5. That was fun. Great. All right, you know what? Hold on. All right, I'm back. So here's what we're doing right now. So I had another one planned. The numbers are nice and tame, so I figured out what I'd do is I'd just go and take the 2 points that I just randomly drew earlier in the video, and we're going to find the equation of this line. Now, it looks like it's crossing it maybe at 1/2, maybe a little below 1/2, but it's hard to tell. I could have drawn my line not very good, and it's not very clear. In fact, it's not really going through that point there, so I'm going to try and get it up through that point. It looks like it's going maybe just a little bit higher than 1/2, but I'm not sure. So we don't really know. So what we can do is we can there are other ways to use the graph to figure it out, but what we can do is we can plug these points in. So that this point right here is -7, 10, and this point right here is 3, 8. So let's go ahead and find the slope using that equation, y2 minus y1. Okay, so that's going to be 8 minus 10. 8 minus 10 over 3 minus -7. Simplifying, we'll get -2 over 10, which simplifies to -1/5. We've got a fraction. That's fine. So then we go y equals -1/5 x plus b. And then what we can do here is plug in one of the 2 points. It does not matter which point you plug in. You just pick something and go for it. So if we'll just pick the first one and see what happens. All right, so if we do the math here, we end up with 10 equals y. So I'm plugging in the first point. -1/5 times x, which is -7 plus b. Okay, that's kind of gross. We have -7, we have a negative times a negative, so the answer is going to be positive, so you can forget about the minus signs for now, is equal to a positive 7/1 times 1/5, multiply across the top, across the bottom, is a positive 7/5 plus b. The x is gone, remember, because we've substituted in. Now we have to subtract 7/5 from both sides. Okay? So our problem here is our y-intercept is equal to 10 minus 7/5. So there's a couple ways you can think about this. You could think about this as a mixed number. You could write this as fifths. Either one is okay. So we'll just do that. I think the mixed number one might be the easiest, but whatever. This, in terms of fifths, would be 50/5 minus 7/5. All right, which will give us b equals 50 minus 7 is 43 over 5, which is 40 over 5 is 8 plus 3 extra. So this is 8 and 3/5. So our equation here is y equals negative 1/5 x plus 8 and 3/5. Did I call that? I think I may have called that earlier in the video. Dang, I'm good. Okay, so anyways, you can sit and graph this. Doesn't cross at 8.5, it crosses at 8 3/5, but you can't really tell that from the graph, or at least not easily. You can tell it very quickly by using the powers of algebra. So ladies and gentlemen, thank you for watching my video. We're going to see you next time with another line video. Boy, lines are fun. We'll see you guys later.